in this example of composition of functions, our input is a number. And so here we have f of x equals 6x plus 1, and g of x is equal to x cubed. And we're going to find f of g of negative 4. Now, first of all, I always tell students, if you can say this, then you can write what it means. And in fact, we read this f of g of negative 4. Now I'm going to look at the definition first. It's f of g of x is equal to f of g of x. And so we say both of these the same way. So basically what we have here, and the basic idea of a composition of functions is one function becomes the input into another function. And so that's the basic idea. So in our problem, f of g of negative 4 is going to equal f of g of negative 4. And in fact, it looks just like the line above, except wherever we had x's, now we have a negative 4. All right, so first of all, as we try to find f of g of negative 4, notice g of negative 4, that's something we could find. We know what g of negative 4 is. We just plug negative 4 into the g function. So we're going to cube negative 4, and that's going to be negative 64. And so this becomes f of negative 64. We just replaced g of negative 4 with what it's equal to. And so now we're just finding f of negative 64. So we're going to plug negative 64 into the f function. And when we do that, 6 times negative 64 plus 1, you should get negative 383. And so that's our final answer here. Now I just want to mention, sometimes students get composition of functions confused with multiplication. And you can see that's quite different than what we're doing here. We're not doing anything in terms of multiplication. It's not f of x times g of x. G of x is the input into the f function. So that's the basic idea here. And that's the end of this video.